Let's take a look at example 1. The log base 2 of 8 times 16. Well, we can multiply 8 and 16 to get 128. So we can say then that this is equal to the log base 2 of 128. So that's asking what power do you have to raise 2 to get 128? Well, that's the 7th power. 2 to the 7th power, so 2 times itself 7 times, gives you 128. So the answer here is 7. We could do this differently though. So we could say that 8 is 2 to the 3rd power, and 16 is 2 to the 4th power. And then if we look at this piece right here, the log base 2 of 2 to the 3rd times 2 to the 4th, let's combine those together using our exponent rules. So the log base 2 of 2 to the power of 7, because 3 plus 4 is 7. So since we're multiplying 2 to the 3rd and 2 to the 4th, we add the exponents. So then we can say, well, the log base 2 of 2 to the 7, well, that's an exponent with a base 2 and a log with base 2. Those cancel out, and we get 7. Okay, well, let's look at this a little bit deeper. So if we split this apart, say that we want the log base 2 of 2 to the 3rd, and the log base 2 of 2 to the 4th. Let's look at those individually. Well, the log base 2 of 2 to the 3rd is 3, and the log base 2 of 2 to the 4th is 4. So to get this answer, 3 plus 4 is 7. And so what we can do with these logarithms is just add them together. So this is where we're going here. That we can split this up into the logarithms being added together. So that's what I have right here, boxed in blue. So if we have two numbers multiplied inside of a logarithm, we can break that apart into two logarithms that are added together with things that are multiplied as the individual logs. We can also do this over division. So remember your exponent rules. When you have division, when you're doing exponents over division, you subtract the exponents. And so we can do this exact same thing, only subtracting the exponents because you're dividing rather than adding them because you're multiplying. And then we also have the power property. So this comes from, remember, we have like say x squared to the 3rd. We multiply the exponents, that'd be x to the 6th. And so here if we have m to the n, we can bring that n down out front and multiply, because again the logarithm gives you the exponents. So if we have an exponent on a logarithm, we can multiply that by the logarithm, because that's what we can do with exponents. We can multiply the exponents together. Let's move on to example 2. So the log base 4 of 21. Let's rewrite this as two separate logs. So we're going to want to try to find a way to split apart 21 into multiplication. So we could say this is equal to the log base 4 of 3 times 7. And since we have 3 times 7 there, we can break that apart into the log base 4 of 3 plus the log base 4 of 7. For the second example, we have the log base 7 of 5 divided by 3. So remember with division, if you have exponents over division, you subtract the exponents. And again, since logarithms give us exponents, they are the exponents, we can subtract the logarithms. So we can say the log base 7 of 5 minus the log base 7 of 3. That's equivalent. Log base 8 of 49. A couple ways we could look at this. One way we could look at this is that this is the log base 8 of 7 times 7. So that's equal to the log base 8 of 7 plus the log base 8 of 7. Well, if you have something plus itself, we can say that's 2 times that thing. So say you have x plus x, that's 2x. Or y plus y is 2y. Or the log base 8 of 7 plus the log base 8 of 7 is 2 times the log base 8 of 7. So that's one way we can get to this simplification. Another way is using that power rule. At the third one up at the top there was telling us what we can do with an exponent. So let's write this with an exponent. So 49 is 7 squared. And so again, that exponent rule told us we can take this exponent and bring it down out front and just multiply it by the log. So this is 2 times the log base 8 of 7. That's another way we can get to the same answer. We have the log base 2 of 125. Again, we have both of these ways, same as 49, to get this simplified because 125 is 5 cubed. So we can rewrite this as the log base 2 of 5 cubed. So we could write that as the log base 2 of 5 plus the log base 2 of 5 plus the log base 2 of 5, or let's just take that exponent, bring it down front, and say this is 3 times the log base 2 of 5. In your homework, you're going to be asked to expand and condense logarithms. Let's talk about what that means. Expanding a logarithm means bringing it out, fleshing it out into as many logarithms as you can write. And so anytime you see multiplication, you can write that with a plus between logarithms. Anytime you see division, you can write that as a minus between logarithms. So on the top of the fraction, we have 5 times x cubed. So we can write that as the log base 6 of 5 plus the log base 6 of x cubed. Then we have divided by y, so we can minus log base 6 of y. Well, there's one more thing we can do here. We have this x cubed in the middle. Well, that's an exponent on a logarithm, so we can take that exponent, bring it down front, and call this 3 times the log base 6 of x. And then fill in the rest. So that would be the expanded form. Example 4, we're going to go the opposite direction. So we're going to take it from this expanded form here, and we're going to condense it down into one logarithm. So first of all, let's take a look at this 3. So that 3, it's 3 times the logarithm, so we can bring that up and make it an exponent on 2. So we could write this as log base 2, not base 2, log of 2 to the third. So that 3 out front comes up and becomes the exponent on 2. All right, so let's write the rest of this in. And now, any place we see addition between logarithms, we can turn that into multiplication inside the log, and so subtraction turns into division inside the log. So we have the log of 9 times 2 to the third divided by 3. All right, so then we have the log of, and then 9 divided by 3 is 3. 2 to the third is 8. And 3 times 8 is 24. Let's see if this marker decides to work. Oh, doesn't want to go. Well, that's supposed to be a 24 there. There we go. Now it works. Okay, example 5. Let's take the equation 2 to the third equals 8. Now, what I'm going to do to this right away, I'm just going to take the log of both sides. You'll see why in a minute. So I'm going to take the log of both sides because that'll get us somewhere that I want to go. So don't worry too much about why I'm doing this right now. I just want you to see what happens when I do. So the log of 2 to the third and the log of 8. We just took the log, and this is the common log, base 10 log of both sides. It doesn't matter what log you use for this. I just happen to choose the base 10 log. Okay, so then we have this exponent of 3 up here. Let's pull this down and turn this into 3 times the log of 2 equals the log of 8. Okay, so when you're solving a logarithm, what you're trying to find is the exponent here. So 3 is this exponent. So let's solve the equation for the exponent. Let's get the exponent by itself on one side. So let's divide both sides by the log of 2. So then we get 3 equals the log of 8 divided by the log of 2. Let's go back to the original equation. Let's set that aside for a minute. I'll circle that. We're going to come back to this. but let's go back to the original equation. 2 to the third equals 8. Let's rewrite that as a logarithm. So this would be the log base 2 of 8 equals 3. So now we have two equations here. We have 3 equals the log of 8 over the log of 2, and we have 3 equals the log base 2 of 8. So that means by the transitive property that the log of 8 divided by the log of 2 and the log base 2 of 8, these two things have to be the same. And so this is what we're going to use to plug logs into our calculators, because most calculators only have the common log and the natural log. And so what you do for doing these in a calculator, if you have something like the log base 2 of 8, you're going to type in the log of 8 and then divide it by the log of 2. So this is called the change of base formula. You can see the formalized version right there. Let's go straight to example 5 and start doing a couple of these. So you're going to want to grab your calculator. And if we have the log base 5 of 8, we can rewrite that as the log of 8 divided by the log of 5. And again, you could use log base 10, the common log, or the natural log. Either one would be just fine. So let's do this. Log of 8 divided by the log of 5 equals approximately 1.3. Log base 8 of 12, okay, so we can write this. Let's do this with a natural log, because again, it doesn't matter which log you use. You can do either one. So let's do the natural log of 12 divided by the natural log of 8. And that will be approximately natural log of 12 divided by natural log of 8. And we get approximately 1.2. And there's the other two right there to check. Make sure you can do those in your calculator.